right? This idea, the first step that's written here, if you have like terms, which we already wrote as a hint, okay, put them together. Our goal is to get the variable by itself. So what do these multi-step ones look like? They just have lots of things in them. But many of the things are like terms. For example, can you see that the 4x and the 3x are like terms? I'll underline those in green. And the 7 and the 21 are like terms. So if we want to put those together, we can only put like terms together if they're on the same side of the equation. So can you see that the 4x and the 3x are on the same side of the equation, but that the 7 and the 21 are on opposite sides? So I could show some work by saying I would like to subtract 7 and subtract 7 to put those ones on the same side. I can do 4x plus 3x. What's that going to be? 7x. And when I subtract 7 on both sides, well, this 7 will go away. 21 minus 7 is 14. So I did a couple steps at once to combine all my like terms. And what did it turn it into? It turned it into a one-step equation. What's the opposite of multiplying? Dividing, dividing. X equals 2. And again, the nice thing about solving an equation is when you're done solving it, if you want to find out if you're right, you can substitute 2 back in for x. And you can ask yourself, what is 4 times 2 plus 3 times 2 plus 7? Well, 4 times 2, that's 8. 3 times 2, that's 6 plus 7. 8 and 16 is 14 plus 7. 14 plus 7 is 21. Do your little happy dance. Because you know you got it right. You can plug it back in, and it was supposed to equal 21. And sometimes when you're checking it, they actually draw a line like this and say this was the left-hand side of my equation, this was the right-hand side. They should equal once I solve them. If they do, boom, I know that I got it right. Okay, do we have like terms here? Absolutely. The 6, I'm going to minus 6 and minus 6 because they're on the opposite sides. But then 2y plus 5y, that will give me 7y. 13 minus 6 is 7. I can now divide both sides by 7. And I get y equals 1. Here I have like terms, but they're all on the same side of the equation. So x plus 2x, that will be 3x. Minus 15 minus 6 will give me minus 21. Opposite of multiplying by 3, divide by 3. And I get x equals negative 7 as my answer. So these ones are a little bit more intense just because we have more like terms that we need to put together. So I'm going to get you to try the next 3 on your own. And once again, I'll put up the answers in a bit. All right, let's see how we did on these ones that you tried on your own. So I would subtract 6 on both sides, so those like terms could go together. 2x plus 4x is 6x. 18 minus 6 is 12. Opposite of multiplying is dividing. And x is equal to 2. Do I have like terms in this one? Yes. The 8 and 12 are on opposite sides, so I'm going to add 8 to both sides. 3y plus 7y is 10y. 8 plus 12 is 20. Divide both sides by 10. And I get y equals 2. Here the like terms are on the same side, so I can just do 3p plus 4p. 3p plus p is 4p. Negative 10 minus 6 would give me negative 16. Opposite of multiplying is dividing. And p is equal to negative 4. So in these first examples that we did, the like terms with the variables happen to be on the same side. The like terms with the numbers sometimes were on the same side, sometimes were on a different side. So in these next examples, and we're going to do these 3 together, now our like terms with the variables are on opposite sides. And one thing I think you've started to notice is if we want to get the variable by itself, we kept all of our numbers or our constants on one side of the equation. We put all of our variables on the other side of the equation. So in this one, I notice that I have a 2m and a 3m, and those are like terms, and they're on opposite sides of the equation. So sometimes what students ask me is, how do I know? Should I move the 3m over, or should I move the 2m over? Right? And some of you can see it already. You would want to move the 2m over because one of the things we try to do is we try to have our variables on one side of our equation and our numbers on the other side. So if I add 2m to both sides, well, then I'm going to get 5m equals 10. This turns this into a one-step equation. We can divide both sides by 5. And we get m equals 2. Same thing here. I notice these like terms. I want to put them on the same side. I would subtract 4a so that my variables are on one side, my numbers on the other. And then we divide both sides by 4. And you get a is equal to 2. Okay, again in the last one, these are like terms. In this case, I would subtract 5x on both sides because I want my numbers on one side, my variables on the other. Opposite of multiplying by 7. Now, if you wrote in this one, because you had your variables on the left and your numbers on the right, or numbers on the right and variables on your left, or whatever, those are perfectly fine. You can write negative 1 equals x or x equals negative 1. That means exactly the same thing. Three more for you to try. Again, I'll give you a minute. All right, I'll put up the answers for this one so you can see how you've been doing. I'd add 4m on both sides to combine those like terms. Five a minus 10a would give you negative 5a. No. So in the last one there, you get negative 6 over 12. That can be reduced to the lowest terms to negative 1/2. Test tomorrow is linear relations, which is all those pattern things and finding the equation and drawing graphs and interpolation and extrapolation. That's what your test is on tomorrow. Or it might ask you the point that you found, was it interpolation or was it extrapolation? So sometimes it can be, do you know the word, which is saying a definition directly? And another type of question is applying a definition. What you found, was it interpolation or extrapolation? Then you'd have to know the definition and apply it. Okay, we're going to do these three together, because now, check out your like terms. My 5x and my 4x are like terms, but they're on opposite sides of the equation. My 1 and my 7 are like terms, and they're on opposite sides of the equation. So here you have some choice. You could either move your variables to the right side and numbers to the left side, or your numbers to the right side and variables to the left side. And it actually doesn't matter which way you do it. You will get the same answer. However, I would recommend, if you can avoid negative numbers, because generally when we do our math, you find you make more mistakes when you have negative numbers, right? So if you can avoid negative numbers, that's going to make your math a little bit easier. So in this example, I might look at my variables. I have the 4x on the right, the 5x on the left. Can you see that if I subtract 4x on both sides, I'm not going to get a negative? But if I subtracted 5x on both sides, I'd be left with a negative 1x. So I'm going to subtract 4x on both sides, which means I am technically deciding, and you'll sometimes hear math teachers say this, move the 4x to the other side. You're not really moving it. You're subtracting 4x on both sides, but in a sense, you're moving all your variables to the, in this case, to the left side. So that would mean I would want to move all my numbers to the right side. So above the 1, I'm going to subtract 1 and subtract 1. What am I left with? 5x minus 4x. I would just be left with an x on the left side. What am I left with on the right side? A 7 minus 1, 6. And crazy, we've solved this equation. It's done. There's no other work to do, because we got x by itself. Okay? I've got a 6y and a 7y. I've got a 2 and a negative 4.
But wouldn't this one be different?
Well, on this one, I would probably move, I would think about going this way.
But either you have negative 6 or positive 6.
But watch this. I go minus 6y, minus 6y.
Oh.
Right? If I move it to that side. And then with my orange ones, the orange ones then have to go this way. So I would have to add 4 and add 4.
Yeah,
What am I left with? 6 on this side and y on that side. I'm done. It's crazy. Okay. Yes. I like to do that. And I like to do that with the variable. Because sometimes you'll have, like, sometimes you can move the lowest variable, but you have to move the highest number. So it doesn't always work the same way. But again, if you think about this here, and this is a great observation, with the 3m and the m, what would make the most sense? It'd make the most sense, you're saying, move the smaller one here, so we're going to subtract m on both sides. Then with these like terms, I would have to put my numbers on the right side. Then I would subtract 2. Okay? Now, when you're doing your work, early on, you might like to show those arrows to remind yourself which direction you're going. As you get better at this, probably wouldn't have to show as many things like that. But what do I have now? 3m minus m, that would give me 2m on that side. My numbers are gone on this side, but on this side I have 4 minus 2. That'll give me 2. This time I'm not done, but I have a one-step equation. What's the opposite of dividing by 2? Multiplying by 2? Kind of gave it away. Dividing by 2. And then I get m equal to 1. These ones, okay? Look how hard this would have been if I gave this to you in words to figure this out in your head. I took 3 times a number and I added 2. And I got the same answer if I took that same number and added 4. What's the number? If I say that out to you now, that's much harder than before. Well, you know the answer is 1 from doing it, right? Because when I started these questions, I said, I have a number plus 2, it equals 5. Your brain has no problem doing that in your head, right? But now we get to more complicated ones. I have 3 times a number plus 2. It happens to equal the same thing as if I took that same number and added 4. When I say that to you, your brain goes, whoa, too much information. I don't know where things are at. I can't do it. And that's the power of mathematics. Mathematics lets us do things that our brain would normally say, that's too hard for me right now. But if I write it out and I follow some simple rules of combining like terms, it's not that hard. And now we get the answer to a question that our brain originally would say, if you told that to me, I couldn't figure it out easily. Okay, 3 to try. even if you're not done these three, okay, again, keep doing them on your own. I will put the answers up. But again, you will not gain anything from copying it down. You gain your understanding by trying it on your own first. Looking at the answers either will tell you, yes, I'm on the right track, which builds your confidence, or it'll tell you, oh, I made a little mistake, or there's a part I don't understand. And if we can identify those places where you don't understand something early, that can help you build your confidence to get to that point where you understand it. So again, I'll show the work on here. I'll talk it through, so if you watch the video later, you can see it. I look for my like terms. Here, I would subtract 4n on both sides, because I want to move my variables to the left side. These are like terms, so I'm going to subtract 6 on both sides, because I'm going to want to move them to that side. That'll give me 3n equals negative 12. Then I just have to divide both sides by 3.
I always like to move them later too.
Mm-hmm.
-0? Absolutely.
All right, so check your answers. You might also like color coding like I did here. It really helps you see your work better.